Hi everybody, it's section 3.1, addition and subtraction of whole numbers. So we want to define what addition means. And this is a scary definition, I know, but I really want you to learn it, and I'll explain it and hopefully it'll look a little better. So here's the definition. Let A and B be whole numbers, and let A and B be disjoint sets. That means that A intersect B is the empty set, but really it just means there's no member in common, so that big A has little a members and set big B has little b members. Then we define the sum of little a plus little b as the number of elements in A union B. So let's see why it's not all strange. Well, really, it's because it's exactly what kids do, just in math language. So suppose I asked a little boy, Justin, to add 2 and 3. So that'd be a plus b would be 2 plus 3. My little a is 2, and my little b is 3. So what's he going to do? He's going to take two objects like cars. Those will be his set A, would be 2 cars. And he's going to pick 3 things, 3 trucks maybe. That's set B. And he is going to throw them together. That's a union. And then he's going to count them. And he counts 1, 2, 3, 4, 5, and the answer is 5. So it's just like the definition, really, if you think about it. Now, we have to be careful. Justin can't pick 2 cars and then 3 more cars, but the 3 cars, some of them are part of the 2 old cars. That can happen with a kid. Okay, I'll do 2 things and now I'll do 3 things, but I forgot that some of those new 3 are really part of my old 2, and then you get the wrong answer. So that disjoint part of the definition is really important. So a few terms. If A plus B is C, A and B are called the addends, and C is the sum. I think you should know these words. We should use sum certainly all the time. And there's some properties of addition that we should learn, and these kind of generalize to other things too. So the first one, if I take a set, and here we're just doing whole numbers today, the commutative property says that order doesn't matter when we add. A plus B is B plus A, 2 plus 3 is 3 plus 2. The associative property, think about your associates or who you group with, and the associative property says it doesn't matter where you put parentheses if you're only adding whole numbers. So A plus, group together B plus C, is going to give you the same answer as grouping together A and B first and then C. Notice here on the slide that the ABC order didn't change at all. I didn't use the commutative property by switching the orders of A, B, and C. I only switched where the parentheses were. There's also what we call an additive identity. An identity is somebody who lets the other guy always keep his identity. So if I add any number to 0, the answer is going to be that any number. Right? 3 plus 0 gets to stay 3. 0 plus 5 gets to stay 5. So 0 is sort of an identity preserver when we add. And finally, the whole numbers are said to be closed under addition. So notice that if I add 2 whole numbers, the answer has to be a whole number every single time. So we know addition. Let's figure out subtraction also. I know when I was in elementary school, one thing I remember very clearly was doing piles and piles of worksheets where it would say something like 7 minus 2 equals 5 because 2 plus 5 is 7. And the 5 would be in a little box in both equations, and you'd notice that they matched. And so that's really the definition of subtraction. A minus B equals C if A equals B plus C. The terminology is a little tricky. I would like you to at least recognize these, if not use them every day. The first number is the minuend, B, the second one is the subtrahend, and C is the difference, and you surely should use the word difference. So we had these properties for addition a minute ago about commutativity. Remember, that's order doesn't matter. Associativity, that meant grouping didn't matter. Identity was the identity preserver who always let the other guy get his way. And closure is the answer of the same kind I started. So you should right now stop this presentation and think about subtraction. Is it any of these things? So stop and think, and when you're done, go to the next slide. Well, I hate to be so negative, but no, 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 it's not any of those things. Subtraction is not commutative. It's not associative. It doesn't have an identity because the identity has to work in either order. And 0 works great when you put it on the right, but it does not work at all when you put it on the left. And subtraction isn't closed because although sometimes when you subtract whole numbers, you get a whole number, like 10 minus 6 is 4, and that's a whole number. But if I go smaller minus bigger, I am not going to get a whole number answer. So we say it is not closed under subtraction, because if even once you don't get a whole number answer, then it's not closed. So let's look at some models you're going to use if you're going to teach. The addition models are a little boring, easy. The first one is the set model. So I want to add 2 and 3. I get 2 things. I get 3 things. I throw them together. I count them. That's exactly the definition of addition, right? That's one model. And the other is the number line model. And I apologize not for drawing these. There are beautiful pictures in your book if you look in section 3.1. If I want to add 2 plus 3, I get a number line. I start at 2. I hop to the right 1, 2, 3, and I am at the location on the number line 5, and that's my sum. Now, how do you teach subtraction? This is much more rich, and some of them are easier than others. So the missing addend is exactly the kind of paper handout that I explained earlier. I say 5 minus 3 is what? To figure that out, I say 3 plus what is 5. And the takeaway model is the second one, and that's the one everybody remembers. The clue of a takeaway is how many are left, how many remain, how many do you still have. Those kinds of verbal cues tell you you're using the takeaway model. And it says A minus B, you take A things, and you're going to remove physically B of them and count what's remaining. So things like eating cookies. I had 3 cookies. My friend ate 2. How many do I have left? The birds were on the clothesline and a certain number flew away. How many are left on the clothesline? That kind of thing. One that does occasionally confuse some 11 students is comparison subtraction. And that tells us that A minus B is what I need to add to B to get back to A. And a clue that this is really the model we're using. In a story problem, you'll see something that says how many more, how much greater than, those kinds of words. So here's a perfect example. Anne is 4 feet tall, Bob is 3 feet tall. How much taller is Anne than Bob? So you see that clue, how much taller. That tells me it's probably comparison. And it certainly isn't takeaway, as you can see on my slide. We do not want to chop 3 feet of Anne's height and measure what part is bloody and gross is left. That would be very cruel and would get us into a lot of trouble. So instead, what you'd probably do is stand Anne and Bob next to each other and measure how many feet from the top of Bob's head to the top of Anne's head, which would be 1 more foot. So that's comparison subtraction. Similar things might be, I have $10, you have $14. How much more do you have than I have? No one's going to take away any of our money. We just have to think, how many dollars would they have to add to my 10 to get to your 14? Comparison subtraction. And the number line model is pretty easy too. We are going to find 5 minus 3 by starting at the first number, just like we do with addition, but instead of moving to the right 3 when we subtract, we're going to move to the left 3. And where we stop will be our answer, which is called the difference. Fact families are very nice. It helps students remember facts more quickly and to relate addition and subtraction. And so you draw a triangle, you would put 3 numbers in the corner so that 2 of them add to the third, and you would ask the student what equations can they make from this family, from this triangle picture. I thought I'd throw in less than just because I don't want to forget. A is less than B if I can add a positive number to A to get to B. Notice that from the number line model, that says that A has to be to the left of B because I'm going to add a positive number, that is, move to the right to get to B. All right, some methods for teaching addition. One really interesting thing if you watch small children, if you ask them to find 5 plus 3, they won't think of the fact that 5 is their whole left hand and then just add 6, 7, 8. So to find 5 plus 3 at the beginning, they will say 1, 2, 3, 4, 5, 6, 7, 8. But somewhere around first or second grade, they may get into counting on. So if I wanted to find 5 plus 3, they might say, okay, 5, and now I'll add 3, 6, 7, 8. So something you're not born with and you have to develop. For students who have trouble remembering facts, it can help them to learn doubles. So you learn 5 plus 5 or 6 plus 6, and then when you have a fact that's close to a double, you just adjust. So 5 plus 6 is 5 plus 1. Now I have a double 5, that's 10, and the 6 gave me 1 more than that, so my answer is 11. You can also adjust when you have a number really close to 10, because adding 10 is easy. So if I wanted to find 9 plus 7, I'd find 10 plus 7 and take 1 off because I did one number too big, 10 instead of 9. You could do something similar with 11 or 8. And another one that's kind of fun and more physical, take an egg carton that usually has 12 holes. You are going to make 10 cups. And then if I want to add 7 and 9, I'd fill 7 of the 10 cups. I now have 9 more. I'm going to fill 3 more just to get to 10. And now I notice I have 6 left that I haven't put in any cups, so the answer is 10 plus 6. And adding 10 is easy.